In this figure, we have a circle and that has been divided into 8 equal parts. Part 1, Part 2, Part 3, Part 4 are shaded parts and 5, 6, 7, 8 are non-shaded. Now, we know that these are actually what? Sectors. Sector 1, Sector 2, Sector 3, Sector 4, 5, 6, 7, 8. So 1, 2, 3, 4, sectors 1, 2, 3, 4 are shaded and sectors 5, 6, 7, 8 are not non-shaded and they all are equal in size. And if you're wondering that what do we mean by sector, then we know that one arc and two radius attached to it makes what? One sector. Therefore, these all are sectors. And just assume that the radius of this circle is represented by small r. Okay, this is the radius. Now, if we take these shaded portions and these non-shaded portions and if we arrange them something like this, like the non-shadeds are here and on the top of it are adjusted these shaded portions, right? So they are very properly fixed with each other. Now, if you notice, this is actually taking a shape of a parallelogram. It's taking the shape of a parallelogram. And if you cannot imagine it, I'll show you. So there is one limitation with this, that this is actually a rough diagram. So it's not very properly aligned in one line, but you have to assume that these all sectors, that is the shaded sectors and the non-shaded sectors are all aligned properly in a straight line. Okay, so I'm telling you what's the limitation, because this is a rough diagram, so they are not very properly aligned. So if you notice this figure, this is actually something like this, and something like this, something like this. So you can see that these are this adjustment, this fixing of the shaded portions and the non-shaded portions are actually approximately of the shape of a parallelogram, right? Okay. Now, if we further divide this circle into 64 equal sectors, initially it was 8. Now what we have done is we have further divided this circle into 64 equal sectors. So initially it was 8. Now it's 64. Right? So what happens if we again take out these shaded sectors and the non-shaded sectors and arrange them exactly the same way we have done here, and exactly the same way we have done here. So something like this happens. Okay, now you can clearly see that these are actually total 64 sectors. On the lower portion are these non-shaded sectors, these white ones, and the shaded sectors have been just adjusted or fixed like these shaded sectors in this diagram. These are on the top, right? So if you look at this figure, this figure is actually tending towards the shape of a rectangle, right? It's looking more like a rectangle. So if I want to show you here, let me show you. What color can we take? Let's take not red, but this. So if you look at this, it's tending towards the shape of a rectangle. Okay, so if you divide the circle into 8 equal parts, it's taking a shape of a parallelogram, And if you divide further this circle into 64 equal parts and you adjust them like this figure, then it's taking the shape of a rectangle. Now, if we further subdivide this circle into more finer and finer sectors, something like this happens. Something like this happens. Can you see? It's actually these fine sectors are, becoming much more finer, much more narrower and narrower and narrower, and they are very much narrow, right? Again, they are turning more towards the rectangle. Not very exact figure because this is a rough diagram, so my apologies for that, but let's assume that these are actually properly aligned. So if you look at this figure, now it's actually tending more towards the proper shape of a rectangle. Okay, what happens if we go on further dividing and dividing and dividing and dividing and go on and so forth up to the point where you cannot even see the difference between these sectors? They are as fine as a thin line, and something like this will happen if you divide them infinitely. You go on dividing the sectors by sectors by sectors, and each sector is further divided into many sectors. Then finally you reach at a point where you cannot further differentiate between the sectors, and those sectors will look like lines. So these will be arranged like lines and they will take the proper shape of a rectangle. Okay, so what's the point? The point is, now if you divide this circle into finer parts infinitely and arrange them then exactly in these patterns, then you are actually getting exact rectangle. Now, interesting thing, what is this length actually? Either from the top one or the bottom one. You can clearly see that this non-shaded portion is actually what? This shaded portion is actually semicircle. Similarly, these non-shaded sectors are actually making a semicircle. One semicircle on the top shaded one semicircle towards on the lower portion that is non-shaded one, right? So this is actually semicircle, and these sectors have been arranged at the bottom part, right, on the base. That means that it means that this is actually the circumference, right? Can you see here? This actually what? These are arcs of a sector. So this whole represent the base of this rectangle. Therefore, this is actually a circumference of a semicircle. Circumference of a semicircle. In this case, the circumference of the semicircle that is non-shaded portions, right? So this is, if you take the bottom one, this is actually circumference of the semicircle formed by non-shaded sectors. And if you look at this one, this whole is actually circumference of the semicircle of formed by shaded sectors. And the interesting thing is that these will be actually equal. This will be equal to this one. So if we represent the circumference of the semicircle by small c. Let's say that we are representing the circumference, or let me write it here, circumference of the semicircle, circumference of the semicircle. Okay, there's some limitations to it. Of semicircle is what actually is 1/2 times 2 pi r, because 2 pi r is the circumference of a complete circle. Therefore, circumference of a semicircle will be half times 2 pi r. It gives you what? Pi r, right? So pi r is the circumference of the semicircle. Now, what will be the breadth of this rectangle? This is length, and length will be what? Is actually the circumference of semicircle, and therefore we can say L is equal to pi r for this rectangle. The length will be actually pi r. Now, we are talking about the breadth. We are talking about breadth. What will be the breadth of this rectangle? Clearly, if you look at this arrangement, this is actually what? If you take any sector, and if you, let me draw it for you. If you take any sector and if you draw from here, what's actually this? It is actually the radius only, right? So any length if you take from here to here is actually radius only. So if this is radius, that means this is all our radius. The straight line that is representing the breadth is actually radius, Therefore, if the radius is r, breadth becomes what? Breadth becomes r. Now, what's the area of a rectangle? Area of a rectangle is given by length times breadth. That this much we know, right? So what's the length here? Pi r, and times what's the breadth here? Is radius. It becomes pi r square. Therefore, area of a circle will be given by pi r square. Okay, let me quickly revise it again. We first divided them in 8 equal sectors, arrange them like this. So these 8 equal sectors are actually taking the shape of a parallelogram. Then we further divided them into 64 equal sectors. They are tending towards the shape of a rectangle. Now, when we further divide them, go on further dividing them, then more and more, they are tending towards the shape of a rectangle. And finally, a point will come where you divide the circle into infinitely many parts, and it will take the shape of a perfect rectangle. Now this length will be the circumference of the semicircle, and this breadth will be the radius. And as we know, the area of a rectangle is given by length times breadth. Therefore, this becomes pi r times r, and that becomes pi r square. The area of a circle is given by pi r square, where r is radius. So let's take a quick example. Let's say that if radius of a circle is 10 centimeter, right? And if we take pi as 3.14, right? So what will be the area? Clearly area is what? Pi r square, and therefore this becomes, what's pi? 3.14, and times r square, that is 10 times 10, right? 10 square means 10 times 10. This becomes centimeter square. This becomes 3.14 times 100 centimeter square. This becomes 3 centimeter square, right? What if it's given that the diameter of a circle is 10 centimeter, or let's say is 100 centimeter, diameter is 100 centimeter, then what will be the area of a circle? Again, we know that diameter is 2 times of radius, therefore radius is diameter divided by 2, it is half of the diameter. Therefore in this case r becomes what? 100 over 2 centimeter, and it becomes r is equal to 50 centimeter, right? So if you put in a is equal to pi r square, so a comes as 3.14 times 50 square centimeter square. This becomes a is equal to 3.14 times 2500 centimeter square, and this becomes a is equal to, so this will be 314 times 25, because 20, so we can remove the decimal point from here, centimeter square. Let's solve this. 314 times 25, 5 4 20, 7 15, 8 2 6. So area comes as 7850 centimeter square. So this will be the area.